In the vast and silent cosmos, where darkness and light dance eternally, there exists an infinite realm of mysteries and wonders, outer space. This is the stage where stars are born and die, where planets wander in graceful orbits, and where galaxies stretch for billions of light-years. It's a place of boundless vastness, where time and space bend before the grandeur of the universe. Among the stars, planets, and nebulae, there is an immensity of mysteries waiting to be discovered. Amidst the depths of space, scientists study the secrets of black holes, gravitational waves, and dark matter, seeking to unravel the cosmos enigmas. But outer space is not just a place of mystery and wonder. It is also a battlefield for human exploration. Space agencies around the world launch daring missions to explore the planets of our solar system, build bases on Mars, and even send spacecraft beyond our stellar system. On our own planets, life flourishes amidst hostile and challenging environments. From the scorching deserts of Venus to the frozen glaciers of Europa, living beings have adapted to survive in extreme conditions, challenging traditional notions of where life can thrive. But outer space is also a place of danger. Asteroids roam the cosmos, threatening to collide with Earth at any moment. Solar storms can wreak havoc on our communication networks and energy systems, while black holes can swallow entire stars in an instant. Despite the dangers, humanity continues its quest for the unknown, fueled by curiosity and a thirst for adventure. As we explore outer space, we discover new wonders and push the boundaries of our knowledge, paving the way for a future where humanity may one day colonize other planets and explore new worlds beyond our own solar system. And so, as we gaze upon the bright stars that dot the night sky, we are reminded that we are part of something larger than ourselves. We are citizens of the universe, cosmic travelers in search of answers to the deepest mysteries of the cosmos. And while we may never fully comprehend the secrets of outer space, we will continue to look to the stars with awe and humility, knowing that they connect us to something infinitely greater than we can imagine. And now let's talk about the black hole, one of the most intriguing and mysterious wonders of the universe. Imagine a point in space where gravity is so intense that not even light can escape. This is the black hole, a region where matter is squeezed to an infinitesimal point, creating a singularity in the fabric of space-time. The history of black holes begins with Albert Einstein's revolutionary theories about gravity. In his general theory of relativity, Einstein described how the mass of an object can curve space-time around it, creating what we call a gravitational field. When a giant star exceeds its critical limit and collapses under its own gravity, it can form a black hole. The result of this collapse is a region of space where gravity is so intense that nothing, not even light, can escape from its event horizon. This event horizon is a kind of point of no return, beyond which anything entering the black hole is doomed to be sucked into its center. But how can we know of the existence of something that swallows even light? The answer lies in the effects that black holes have on the space around them. When matter is dragged into a black hole, it forms an accretion disk around it. This disk emits enormous amounts of energy in the form of X-rays and other forms of radiation, making black holes visible to astronomers even though we cannot see them directly. Black holes come in different sizes, from stellar black holes, which form from the collapse of massive stars, to supermassive black holes, which inhabit the centers of galaxies and have masses millions or even billions of times larger than our Sun. The discovery of these cosmic giants has revolutionized our understanding of the universe and how galaxies evolve over time. But black holes are not just insatiable devourers in the cosmos. They also play a fundamental role in the formation of stars and galaxies. When matter is pulled into a black hole, it releases huge amounts of energy, heating the gas around it and triggering the birth of new stars. This phenomenon, known as black hole feedback, is one of the most important processes in the formation of cosmic structures. However, black holes also represent one of the greatest mysteries of modern physics. Einstein's general theory of relativity accurately describes how black holes work, but it fails to describe what happens at the center of a black hole, where the laws of conventional physics no longer apply. To fully understand black holes, scientists need to develop a theory of quantum gravity, which unites quantum mechanics with general relativity. And so, as we continue to explore the mysteries of the universe, black holes remain cosmic question marks, challenging our most fundamental understanding of the nature of space and time. But, at the same time, they inspire us with their beauty and majesty, reminding us that the universe is a place of infinite complexity and wonder. After you understand the black hole, this is the beauty of the stars within it. Yes, you read that correctly. Although it may seem contradictory at first glance, it is a fascinating idea that stars can actually exist within these deep and dark gravitational wells. But how is this possible? The answer lies in the phenomenon known as neutron stars. When a massive star reaches the end of its life, it can undergo a catastrophic collapse, resulting in a violent explosion known as a supernova. The remaining core of this star, primarily composed of neutrons, can further collapse, forming an extremely dense and compact neutron star. Now, imagine that a neutron star is orbiting a black hole. As it approaches the event horizon of the black hole, gravity becomes increasingly intense. Eventually, the gravitational force is so strong that it begins to stretch the neutron star towards the black hole, creating a phenomenon called spaghettification. This process distorts the neutron star into an elongated shape, like a strand of spaghetti. As this happens, the neutron star begins to release enormous amounts of energy in the form of X-rays and other forms of radiation. This radiation is emitted as the material of the neutron star is compressed and heated by the intense gravitational field of the black hole. As the neutron star approaches the black hole, it becomes part of the accretion disk, a region of material that spins around the black hole before being swallowed by it. In this accretion disk, the material is heated to extremely high temperatures, causing it to emit huge amounts of energy in the form of visible light, X-rays, and other forms of radiation. But what about stars that are not neutron stars? Can they also end up within a black hole? The answer is yes, albeit in a different way. Ordinary stars, like our own Sun, can be torn apart and engulfed by supermassive black holes residing in the centers of galaxies. This process, known as tidally disrupted star, occurs when the gravity of the black hole exceeds the gravitational binding force of the star, resulting in its complete destruction. So, although black holes are famous for devouring everything in their path, including light, stars still manage to shine within their dark domain. It is a fascinating irony that, within these feared cosmic objects, there can still exist such radiant beauty. After all, in the universe, beauty often resides where we least expect to find it.